Hi everyone, welcome to another Physics 210 online lab simulation walkthrough. As always, my name is Alec, and today we're going to be having a chat about ballistics and conservation of energy by way of a ballistics pendulum and projectile. So if you haven't already, please, of course, read through the attached ballistics lab manual. That has some nice theory and stuff in there that you can read through, and also details how to calculate all the errors and stuff associated with this lab. So please do go ahead and make use of that before you start watching this video. Next up, make sure that you head over to this website here to open up the simulation and ensure that we used it before, but we're going to be making use of Pixel Zoomer once again, which is a Google Chrome extension to make some distance measurements and such. Of course, I've listed some relevant equations for you here, so feel free to explore those in your own time. But for now, let's go ahead and jump right into it. So, before we really get started, I'll show you here. The simulation runs pretty fast. As you can see, it would be kind of hard to take measurements if it kind of just did things like this. So what you can do is, if I hit reset here, hit play, then hit pause right away, and if you hit the step button, you'll notice it'll actually advance or rewind frame by frame for you, which is very, very handy. So we'll be making use of that throughout the remainder of this video. And of course, one other thing, assume that the gravitational potential of the pendulum, so this guy here, is 0 when it's at rest. So right now we would say that the gravitational potential energy of this thing is 0. Alright, so setting this up, first we're going to vary the mass and see what happens when we do stuff. Essentially, as you can imagine, what's going to happen is if you had this bullet with some mass and some speed, it hits this pendulum, the pendulum is going to rise up and eventually fall back down, but we're concerned about the point where it rises up. And if I were to lower the speed here, or lower the mass indeed, it would affect that in a certain way that we will figure out. Alright, so we're told to set the bullet speed to 100 meters per second, set the mass of the target to 1,000 grams or 1 kilogram. We're going to leave it like that the entire experiment. Set the pendulum length to 2 meters, and again we're going to do that for this whole experiment. And we're going to set the mass of the ball, in this case, to 10 grams. So there we go. And now it says to use these initial conditions and using the equations above, calculate the height that the pendulum will reach after it is hit with the bullet or projectile. I'm going to leave that for all of you to do. If you have any questions on how to do that, please feel free to email me, or we can talk about it in a discussion session or what have you. Next it says to use Pixel Zoomer to measure the number of pixels from the tip of the rope, so here, to the top of the ball, and we can call that well, earlier when I did this, I found it to be about 200 pixels. So 2 meters, 200 pixels means that 1 pixel is about 1 centimeter. But just by way of example, I will show you that again. So if I set the point here and click and drag, you want to have it to be 1 by whatever it is. You don't want to measure some kind of weird triangle kind of thing. So make sure that the quote-unquote snapshot you're taking is 1 by whatever. And you can see around the tip of the rope, it's really close to about 200 pixels. So that means that in this case, 1 pixel is exactly 1, or nearly exactly 1 centimeter, with a bit of error in there. Okay, so now we are told to fire the projectile by pressing play and then immediately press pause, which I've done here. As you can see, it got there pretty quickly. And now we're told to use the step button, which is this one, basically click it a bunch of times until the simulation, so the simulation moves forward until the angle starts to decrease. So if you read off the angle right here as I do this, I'm just going to click it a whole bunch. You can see the angle is rising, 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 rising. This might take a little while. It keeps going up and up and up and up and up. Okay, so what I'm going to do is find the point at which it stops increasing. So we're at like 12.76, 12.8, 8.84, and as you can see, it stops and then it goes back down. So any of these frames here are going to be just fine. So I'm going to use this frame here. Now it says to use Pixel Zoomer to draw a straight line from basically the tip of this rope to down to the original height, or the original range, so 200 pixels. And then you're going to use Pixel Zoomer to kind of measure the height of this thing. It's a little confusing at first, but I'll show you what I mean. So I'm going to take Pixel Zoomer, I'm going to open it up, and move my cursor such that it is exactly where it was when we had it before, when we measured it to be 200 pixels. So alright, so it's like right there. Now we're going to head over to where, basically just under the tip of the rope. This is a bit imprecise, but we're making do with what we have. So right about there. Okay. So this length actually doesn't matter, but what you're going to do is use that to measure the height that the pendulum has risen. At first, it's not going to be a whole lot. Okay, so you can see this is about 1 by 10. So in this case, it looks like the pendulum has risen about 10 centimeters from its original position. So in this case, for the first little point here, the height of the pendulum is going to be about 10 centimeters. And now we're told to repeat steps 5 through 12 using the projectile masses of 15, 20, 25, and 30 grams. And essentially, this experiment is just going to, or this simulation really, is just going to be a whole bunch of different, doing the same thing over and over again, which is that, just with different masses and different velocities. So we can just crank through those real quick. So I'm setting it to 15 grams, or attempting to. Okay, there we go. I'm going to hit play, hit pause, and you can see this time our angle is actually quite a bit higher than it was before. And as I advance through the frames, right now it's increasing, and I'm going to wait until it starts to decrease again. Okay, and then I'll back up to the maximum. So this is, again, the maximum angle. I will use Pixel Zoomer. Go ahead and open it up to drag down to about 1 by 200 right here. Oh, there we go. Okay. And then just while you're gonna like unclick the mouse, click again, and drag it over to just under the rope. And you can see there's a bit more distance now between the rope and our cursor. And now we've measured it to be about 15 centimeters. So again, increasing the bullet mass to 15 from 10 increased the height of the final pendulum to about 15 centimeters. So make sure that you're marking this down as we go. Again, the original with 10 grams was about 10 centimeters. 15 was about 15 centimeters. And let's advance over to 20 grams to see what happens there. Okay, so I'm just going to step through this real quick. And you can see, again, angle's increasing, and it just started to decrease. Go back to the maximum. Open up Pixel Zoomer. This is a bit of a tedious process, of course, but what would a physics lab be without a little bit of tedium? Okay, and so I'm going to bring it down to about 200 here, drag it over here. And again, when you're doing this part here, you just want to make sure that you're doing it as close to the original as possible. So you know that right now our y-coordinate is exactly 200 from the box here, and so if you keep it x by 1, you know that you're still on that 200 centimeter 2 meter line. So now if I click it again, now we're still at 2 meters here on the we're still at 2 meters on the y, but we can measure up to the rope and figure out exactly how far up it's risen. So in this case, it looks like it was about 23 centimeters. Sorry, I missed that a little bit. You can see it's about 23 centimeters. So in this case, so for, 20 grams, the pendulum ended up going up by a height of about 23 centimeters. All right, so let's increase this up to 25. This is the second to last measurement for the mass increasing portion. Go ahead and hit play. Okay, I didn't hit pause soon enough, sorry. There we go. Okay, so, and again, you'll notice every time the angle is increasing, because ostensibly, as we increase the mass, we are increasing the kinetic energy of the ball. So it's going to increase the angle and also increase the height of the pendulum. Okay, so it looks like the maximum here is about 31.98 degrees. And I should mention, this angle is actually from, if it wasn't obvious, it is from the vertical. So it's not this angle here, it's this angle that it's kind of swinging from, right? So okay, I'll go ahead and open up Pixel Zoomer, and we'll make that measurement again. Okay, so about 1 by 200. There we go, my mouse is a little sensitive, so it's kind of hard to do it exactly. There we go, and I'll measure this one. Okay, and back up. Cool, so it looks like it's about 35-ish centimeters. Let me double check here. Yeah, about 35 centimeters or so to the tip of the rope. And let's move on to our last one. So again, for 25 grams, it was about 35 centimeters. Hit play, pause, and I'll advance up to the maximum angle. I think it should be around somewhere around 38. I did this one before. Okay, yeah, right about 38.41. Awesome. Now, open up Pixel Zoomer. Go down by 200 pixels. There we go. And of course, in my language, I'm using pixels and centimeters equivalently, because in this case they actually are. We measured that out to be true earlier. And okay, we're just under the rope here. And measure up to the rope. and I get about 46, 47-ish centimeters. You could probably justify, anything between 46, 47, 48. So again, for 30 grams, the pendulum rose about 45 centimeters. Okay, so make a table with all of that, or with each of the bullet masses and each of the pendulum heights, the final pendulum heights, as well as the ones that you calculated. You'll want those eventually. And we'll move on to part 2. So as far as varying the velocity is concerned, what we're going to do is I'm going to reset this here. We're going to leave the mass of the target and the pendulum length the same, and we're going to vary this time the speed of the bullet. So I'm going to decrease the speed of the bullet to 50 meters per second, and we're going to leave the projectile mass at 30 grams. Okay, so, and of course, what's going to happen is after every step, you should calculate using those initial conditions, calculate the height of the pendulum. It's going to be the same process, except that this time you're going to be varying the bullet speed. Okay, so it says after you've done all of that, to repeat steps 5 through 13 in the above section for each of the masses of, 60 meters per second, then 70, 80, 90, and 100. So I'll set it to 60. And we'll just crank through those measurements real quick here. So play, hit pause. Actually, let me let that go for, I messed it up. Okay, there we go. Okay, so bring it up to about its maximum here. So it looks like it's going to be about 22.77 degrees. And then I'll use Pixel Zoomer to calculate the height difference, or to calculate the height of the pendulum rose. 1 by 200. Okay, now over to the ball. Just under the rope here, and looks like we got about a height of 22 centimeters for this one. Sorry, I know that one was a little quick, but this one was 1 by 22 centimeters is about the height that it rose up. And again, I just want to state it again, that what the Y measurement that we're making here is indeed the height in this formula up here, the MGH. So you'll be using all of these values for H, and of course calculating H. So now if I go back and reset this, we're going to go up to 70 meters per second, and you shall see what happens. Alright, let me get to the maximum angle here. It takes a bunch of clicks. I'm clicking very quickly and trying to stall by talking, which I'm not very good at. Alright, so it looks like we're about 26.62 degrees is our maximum here. I'm going to open up Pixel Zoomer once again, drop down to 1 by 200, over to under the rope, and measure up. And it looks like we got about a height of about, 25 centimeters this time. So again, 25 centimeters for 70 meters per second. And back to the simulation. Up it to 80 meters per second. Play, pause, and stall until it gets to the highest degree. Maybe you can hear me furiously clicking away. Alright, so it looks like the maximum angle here is 30.51 degrees. And we'll just run through this real quick. Drop down to 200. Drop over to just under the string here. And it looks like that height is about 33 centimeters. So 33 centimeters for 80 meters per second. Reset, jump up to 90. So this is the second to last measurement. And find the maximum angle. Alright, looks like we're at about 34.44 degrees. And of course, the angle measurement doesn't matter quite as much as it does. We're just using this to get an idea for what the maximum height is, because of course the maximum height is associated with the maximum angle in this case. So if I drag this down here, go over and up to the height of the string. So it's about 36, somewhere around 36, 38 centimeters. I wouldn't fault you for picking anything in that range, because again, there's a little bit of error associated with using Pixel Zoomer here, because I might land on an incorrect pixel. But again, about 38 centimeters at 90 meters per second, and finally up to 100 meters per second. All right. Oh, actually, we got pretty close there. All right, so we're at 38.41 degrees is the maximum. And let's measure the height here. 1 by 100. Come on. There we go, 1 by 100, and move over to under the string here. Measure up to the string. And it's about 49, somewhere between 49 and 50 centimeters that it rose up. All right, so that should be all of the measurements that you need for this. There's some data analysis questions and such. Those should not be terribly difficult. If you have any difficulties, feel free to email me, or we can talk about it during our discussion session. But apart from that, if you need to rewatch this video or whatever to retake the data, or if you just needed to use it as a guide, feel free to use it as you see fit. And I hope this helped. Have a great day, everyone.